All right. Welcome, everybody. My name's David from Memphis Game Developers, and this month we are going to be talking about Unity multiplayer networking. I guess a bit of history with this is MLAPI was mid-level API for I guess it was during the UNet networking days, where Unity supplied the low-level networking, and a group got together and made a mid-level API on top of that. They have since been purchased by Unity last year-ish, and Unity has since started integrating that into the actual engine. They have since recently, in the last month or so, renamed MLAPI to Netcode for GameObjects, which makes it hell to actually Google search for, because that is a generic name for basically any kind of networking code. But here we are anyways. So it also makes searching YouTube videos really weird, because you'll end up with a lot of old videos if you search for MLAPI. But for right now, all of this documentation is up on Unity right now under docs-multiplayer.unity3d.com. We'll have a link to this in the description there. But right now it's still in preview access. So to actually install this, you need to go in through the package manager and actually install it through a GitHub link, which should still work here. If you copy this, and this actually might be an old link, because that says MLAPI. But if you go into your package manager and click on this plus here, you'll be able to install it through Git. Here, package manager. Here, you'll install through a Git URL. I've already got it added. And you'll see it show up as MLAPI networking library. Soon that will say during the next 0.2 release, they'll probably rename this to networking for GameObjects. So this is just for migrating and whatnot, but that's fine. So after you get it installed, the first thing you actually need to do is set up a network manager. And the network manager for now is going to live on a game object in your scene, and it's by default it's set to don't destroy on load, so it'll persist throughout scene changes and stuff. We'll go over the network prefabs in a bit, but for anything that you are going to be spawning and despawning throughout and syncing between server and client, you need to register all of your prefabs so it knows what it is actually looking for. By default, you'll need to have at least one default player prefab, and by default this is set up to actually spawn your player when you actually connect. You'll have a game version, a protocol version here, The network transport is actually the low level, like the socket connections and whatnot for your networking. It comes with the UNet transport, which is kind of the old Unity transport layer. There is a new one that they are about to release here soonish. That's just I think it's just com.unity.transport. I think in the package manager, but you don't actually have to know about any of this for right now. Just know that you can use your own transport layer. So if you are, where is the? I guess it doesn't actually let me switch unless I go to none. I'll do this real quick. So this is what you'll see when you actually first pop in a network manager. You actually won't have a transport layer, but you can install the UNet version. There is different ones for, there's like eNet and LibNet, LightNet Lib transport. There's also the Photon transport layer. There's one for Steam P2P. It's actually up on GitHub here. I can pull it up. It's in the documentation as well. But these are actually made by the community. Let's see where. Here we go. So here we have there's Ruffles, eNet, Steam P2P, WebSockets, Photon Realtime, FacePunch, which was the Steamworks guys. And these are just all community-made transport layers for MLAPI that you can use that has various other features to it, but that's for more advanced usage. I do want to look at that lag compensation. Anyways, so yeah, so I'm just using the UNet transport here. By default, you can set the tick rate and the network tick interval. This is going to be changing here soon with the next 0.2 update. They're reworking how the network tick rate actually functions, and I believe the entire like network update loop is getting changed. You need to enable network variables. This is how you actually sync variables between the client and the server. I'll go into more of this when we get into the code, but this is important to have checked. You can also ensure network variable link safety. I think that's just checking for like buffer overflows and whatnot. The connection approval. This is for if you have like room names, and I know Photon uses rooms and room names. This can also be used. We'll use this for spawning different player prefabs other than the default prefab for like selecting characters and stuff. For the spawning here, we have create player prefab, and this will automatically create your player prefab on connection. Sometimes you might not want to do that if you have like a lobby system where you are selecting a character and then you want to spawn into the game. If you uncheck this, you'll be able to spawn the player prefab manually. We will also, for setting up an actual dedicated where is it? Here it is. Force prefab sync. When you have a separate project for the actual server, which I'll show you guys here in a second, this use prefab sync will force a reload of all of your network objects in the clients to match up with the server project. So if you're just using regular server hosts or client host setup for your game, you'll want to leave this unchecked. But I'll show you how this works here. There's also scene management here. So if you want to have multiple scenes in your game, you'll need to have the server needs to be on the same scene as the clients. Otherwise, they'll desync, and when a scene changes, the server like unloads everything from the old scene and loads up the new scene. And if the clients aren't keeping up with that, then they'll be sending data to GameObjects that don't exist on the server. So you will need to, if you have multiple scenes, you'll need to enable the scene management to keep everything in line. So when you change a scene on the server, it'll automatically change the scene on the clients. And then we have our start host, start server, and start client. The difference between a host and a server is that the server or the host actually is running both a client and a server in the same instance. And servers are just a server and clients are just a client. So what we'll be doing is in our second project here, we'll be starting as a server, and then we will start this project here as a client. And down below, when we select our network transport, it adds this transport component down here. And this is the actual like IP address and port data that we'll be using to actually connect to it. We'll just be using the default, the local host here. So we'll just be connecting to the same computer. But if, for example, this would be like your, Amazon AWS server address here, or whatever your matchmaking system spits out that we talked about last month, like through PlayFab. This is what you would use to connect all that together. There is an MLAPI relay project that you can run for that punch through. If you want to do like a P2P game, you'll need to actually set up a relay server to connect people's internal networks together. I haven't actually tried this. I'm not sure if this is a test server or what. So let's actually pop over into our server project here. So this is our server. And you need to make sure that your settings for your network manager are the same as your client. Otherwise, you'll get like a network config mismatch error, I think it's called. And your project doesn't have to be named the same, but we'll go over the prefabs and how that works here in just a second. Here, make sure. Okay, yeah, I'm just a unit here. All right, so let's hop over into some code. Here. Let's close all the others. Okay. So in your actual code here, what we are doing is this is my game manager script. And instead of inheriting from mono behavior, we are inheriting from network behavior. And network behavior is basically a mono behavior that has some hooks into MLAPI and our network stuff. For, I guess we can talk about the network variables and actually how they work. So the network variables, what they do is they will automatically sync from the server to the clients. By default, they have permissions set up on who can write and who can read to them. When the server updates the clients on a change, in this case, this is a network list, which is a list of players. And I was using this to just keep track of all the players that have joined the game. And basically, you can subscribe to there's an on list change for network lists. I believe network variables have an on value change, and you can just subscribe to it. And that here's the list update. So whenever the server updates the list, this gets fired off, and then you can do what you will with that change. So if it's like health, then you can like update your UI, and you can damage the player, particle effects, whatnot. The other thing I'm doing here in Start is the network manager is a singleton for now. I believe this is actually going to be changing as well. So you can actually have multiple network managers running at the same time. But for right now, it's a singleton, and they have various callbacks that you can hook into on the client. I'm just hooking into, there's on client connected, and there's on client disconnect. This is also network connection data for when we are using the connection approval function here. We'll show that in a second for the server. And then you can just start client. Normally, you probably wouldn't do this in Start. You would, do this in your menu, but I didn't feel like hooking up any UI, so we're just doing it in Start. And there is built-in logging here, which is actually kind of neat. I just got this set up last night. But if you use MLAPI.logging here, you get access to this network log. So what this will do is when you call this, it's basically a debug log, but it also will get sent back to the server, which is good for like playtesting and stuff. You don't always have access to whatever client is running, but you should have access to your server. And I think I got it. Yeah. So here, when I connect, this will call log info server, client has connected, and then here in our server here, you see that it has the sender equals 2. This is the client ID, and it just says client has connected. And I think this also gets written out to the actual log file as well. So let's actually see this function here. And yeah, so what we'll do is we'll just start our server here. And what should happen is when we connect, it is going to automatically spawn in our player capsule here as our prefab. On our client, we also have the player capsule as the default. For the actual prefab here, this is actually super important, especially doing a split project like this. So the way network objects are kept track of in MLAPI is through network objects. So everything in our scene that's going to be spawned and synced up has to have a network object. Now, let's see here. So the actual prefabs themselves don't have to be identical. So here we have our player capsule on our client side has this grayish silver color to it, and on the client it's just like the default gray capsule. I mean on the server. This prefab hash, this is what MLAPI is actually using to spawn and despawn our prefabs. This is what it is actually registering in the network prefabs here. The other thing that you'll need to know for, I believe also for network variables, as well as RPCs, which are the remote procedure calls. We'll get into that here soon. But the actual prefabs don't need to be identical, but they do need to have the correct components in the right order. So for this player capsule prefab, it has our network object. The animator is actually disabled for this one because it's not actually animating. The character controller, the network transform, which is here. So the network transform is just a component that is going to be syncing the rotation and position of this game object to the server. This one here by default is actually client controlled. So on the server, I can't actually change the position. We'll show that here in a second. In the next update, I believe they are introducing a server authoritative network transform. And that just means that you'll be sending inputs from the client to the server is going to be updating the position and then sending that back to the client. And just due to physics and the speed of light and whatnot, that is introducing a little bit of delay from when I hit up to when the player actually moves. And there's you can do some interpolation and some compensation to mitigate that, but it's actually super complicated to do. So this one has, there is like a snap distance. So if your network connection flakes out for a little bit and you end up moving farther than the last update after I think 10 units, I think this is, it'll just snap to it instead of trying to lerp over to it, just to keep everything lined up and in sync. There's also channels that you can have in MLAPI. Like you can have unreliable channels and reliable channels just for like UDP and TCP. I think by default, this is set to reliable, I believe. But let's pop this open. And see what happens here. So this is on the client, I mean on the server here. And on our client, we will start and we should see our capsule buddy pop up. Yay. We connected. Oops, not that. Here. Do that. Okay, that's cool. So, where'd my mouse go? All right. So yeah. Oh, I think I have this thing locking the. Should change that. So this is using the third-person controller from the essential assets with the new input system. And I think this thing locks the mouse somewhere. I'll fix it later. But in our net manager here, we can stop the client. And there we go. Oh, that's annoying. All right. So, I guess that we could show how. All right, so here, sure, set the same. So it actually won't let you have two default player prefabs checked at the same time. If you don't have a default player prefab, you'll get this error message here that there is no prefab selected. Here. I don't think this order matters. We'll find out. So here in our client, a little bit bigger. we have this player armature. So this one is a little bit more complicated than our little capsule dude. This has a full animator here set up. And on our prefab on our server, it doesn't need, I don't care about its actual animations going on. I don't need the player input on the server. And I don't actually need any of this the starter asset stuff on on our client prefab. All I need is the the transform to keep track of the rotation and position of the player. But I do want this network animator. This is a separate component that will keep track of the animations to other clients that are connected. I don't know if I have this one built out or not, but we can do that real quick. So what this will do is on our prefab here, this will keep our components or parameters for the animator all synced up. Now, this will not sync triggers in the animator. So, where is here? So our parameters are the speed, jump, grounded, free fall. These are just bools. If we were to add a trigger, that actually does not get synced up. So you just need to keep that in mind for your animations. But for our actual prefabs, like I said, the actual prefabs don't have to be identical, but the component list and order actually does matter. I don't remember if I said this or not, but the prefab hash here, that only it hashes the actual name of the prefab, or it uses this string here. So even though this is player armature prefab and this is just a player prefab, I overrode that here in the prefab hash generator to be player on both sides. And then just make sure that this hash is the same on both sides. So even if we put a space in there, the hash changes, and this would like break everything. So this all should still work. I don't think I broke anything. We'll find out. So we'll start our server. And then we'll start our client. Huzzah. Yoink. Okay, and you should disappear. Good. So what I'll do right now is we'll just build and run this, and it shouldn't take too long. While that's building, does anybody have any questions so far about this?
No, that's pretty cool. Are you gonna demo it with 2 clients?
Yes, we are.
Sweet.
Oh, I guess I should have had my. That's what I get for not having UI.
Start the server first.
Yeah. Okay, so we will start our server. Actually, should have just left it running. Then this. So, oh crud! I don't know how. The input system is kind of weird in that. Crud. Well, you can see here that the animations do sync up, and in our server here, it's just you know, capsules running around. And honestly, I don't even need the capsules here for the server. It'll be running headless, and that just means there's no graphical components running at all on it. But this is just for streaming purposes. So we can just close this. Don't know why that doesn't work sometimes. All right. And actually, we can just show that real quick. So to actually build the server out, what you do is you just make sure that this server build is checked. And that enables some build defines for servers. And also, I believe this will just run headless by default on your actual machines.
So, how much of that do you have to worry about? Like, if you included the capsule, for instance, versus not including the capsule, is that going to make any difference? I mean, like, how much should you think about making the server a totally different program with nothing except transforms and rotations?
Um, for the actual build, it doesn't really matter because it's not displaying any graphics anyway, so you don't have to worry about polygon count and whatnot, or frame rates and stuff. So yeah, it doesn't really matter. It's just really just to demonstrate the point.
Cool.
So let's show the connection approval. So with this checked, it will actually run a connection approval callback here. I have that on the server side. And just got to make sure that they are both checked and server. Yeah. So here in our client, right before I called start client, I set this network config connection data. And right now I just set this to a room name. This can be really any data you want. It just has to be serialized out to a byte array. So this could be just like a JSON file for like selecting your character and like, like level difficulty and stuff for like matchmaking and whatnot. So this is our server. And for here, I also have a on connect and on disconnect, but there is also a connection approval callback. And this only gets called when that connection approval option is checked. And when that gets called, it gets passed in that connection data byte array, the actual client ID, which all the client IDs here are ulongs. and also a callback that gets called. So for here, you would do some kind of check to make sure that the connection data that you sent, you can check for like make sure that this is the same room name that this connection manager is set to. I'm not doing any of that right now. We're just go ahead and just setting it to true. This is just going to be to set a new player prefab for our different characters. And what I'm doing here is I have a list of player characters, which I set up here at the top. Here, just a regular list of game objects. And I'm just getting a random number of, I only have 2 set up for actual client stuff. And it is generated from the name. And then once I have that, then you have this callback that's going to get automatically called. And then you just pass in the create player object, your prefab hash, and the approval, where you're going to actually spawn, and the rotation to actually spawn in. So what will end up happening is on our server, in our game manager, I just have a player and our player capsule. In our client, I actually don't have anything set up here. What you would normally do is you would have the same prefab set up here, and you would send it. You would have like a UI set up for like, choose your character here. Then you would add this into your connection data. That would get sent over to the server, and then it will spawn whichever one of these you have set up. Like I would pass in the index for the player character. So you would make sure that the player, which I think is the armature here, would be first, and then the capsule here would be second. So you would send in, if you want to spawn in with the human character, you would send it index 0. If you want to spawn in with the capsule character, it would spawn in index 1. But for now, because I'm lazy and didn't want to do any UI, it's just picking a random character on the server side to pick which one. So we'll go ahead and run our server. Here, we'll run our client. Sure that works. Yay. And whoops, forgot. I need to rebuild this one. Yeah. Server here, and still doesn't work. I think it's because the standalone client is eating my input. But it's fine. Ooh. Cursor go. Okay. So yeah, this is the way that you get your prefabs to spawn different players for your different clients. Let's see, we went through network variables. You can set up network variables for any of the Unity primitives. So things like your, your string, actually strings are going to be changing here soon, but ints, floats, bools, I think strings are getting changed to either character arrays or I think they have a separate string variable that they'll be using because strings are weird in C#. Let's see. Data network objects, connection approval. Boop, boop. Let's talk about object visibility. Actually, wait, I have some other stuff set up here. I think this will work. Maybe. So, in our client here, we can show off some syncing of network variables. And here we have a little chat system set up, I think, maybe. Should be. Here, that's fine. Okay. So here is a simple chat system. What I'm doing here is down there, creating a network list of strings, which is going to be our chat messages. And when you create a network variable, you need to set it to a new network variable of that type. And you can pass in network variable settings. And these are your permissions that you set up. So there is read permissions, which I'm setting this up for everybody can read this this variable and everybody can write to it. By default, only the server has write permissions, and every client has read permissions. So I believe the different permissions is custom, everyone, owner only, or server only. So if you have a network variable on like your players, you might want to set the read and write permissions to be only the owner can write to this. But if you're doing a dedicated server setup, you probably don't want to be trusting the client anyways. So, but this is just for demos and for a chat system, people need to be able to write to this. I guess the other way is you could send your strings to the server and then have the server update this network list variables. But either way, it's fine. So when we change this list, this will call this chat updated, and all that's going to do is add a that message to our list of um, of strings, and then we'll see that. I thought yeah, I guess I don't have like usernames set up or anything. Do that real quick. Yeah, I'm not going to. All right. That is on player, and I believe I need to. We'll just throw this on our server object. Here. So this is on the server. You need to have the same network variable set up on it with the same permissions. And that's basically all you really need. These are for the RPCs, which we'll talk about here next. And this out. Build. Okay. That is not going to work because it is going to be looking for this prefab. So what I need to do real quick is create an empty, let's call it chat system. Chat system. And this need a object. Got to make sure the hash is the same. And so yeah, everything that is a network behavior, right? Everything that's a network behavior has to have a network object attached to it as well. So that's just something you need to keep in mind. Now that should work.
So, can you explain why the input and the box are not showing up on your other side?
On the server side?
Right.
Yeah, I just don't need it. This is just on the client side, so server doesn't need to have the input box on it.
I'm just wondering, like, why. So, in your chat system variables, why those variables are not showing up on the server side?
Oh, it's a separate script.
Okay.
It's a whole different project. I just named it the same.
Okay, gotcha.
So now let's see. Oh no. Crud. Okay. I will need to make this a prefab. And I need to add this prefab to our list here. Okay. And this error message is showing up because we have the prefab sync set up here. So with prefab sync, everything that has a game object on or a network object on the server side is going to try to get spawned on the client side. And we have to make sure that this is on our okay. This should work. I guess I need to rebuild. Okay. That crud. Let's see. To check this. Still. Let's try this again. Sure. Actually. And I hate stuff. Okay. So that should work. It's not working. But do. Got to put the event system Okay. Save that. Yay. Okay. Run. So yeah, this is super simple variable syncing up. Um, don't know why client keeps freaking out when the client is running, but it still syncs up. Even on reconnect, the server is keeping track of this. It does not sync up automatically. Yeah, that does work. There's probably a way to set it up. Oh yeah, I think I know what's going on now. To actually sync up on connection, I think you just have to set the variable, set it as dirty on connection, so it automatically syncs up instead of waiting until you send something and change to the variable. Because this the server, this on list change up function here only gets called when the list actually changes. So it's not actually syncing up like on update or whatever. Okay, so let's talk about RPCs and remote procedure calls. So on, do we have any on the game manager? Yeah. These actually aren't doing anything, but it's enough. So the way RPCs stands for remote procedure calls. These are functions that it gets called on one system and it gets run on another system. So server RPCs, they get called on the client and then get run on the server. On the server side, I don't have client RPC set up here, but on the server side, on the game manager script, you have the same function signature here. You do have to make sure that the signature is the same because that's part of what gets sent over here. So for this send player to server RPC on the client side, this will send the player data. This is a struct that I made that will contain some player data, and also we'll send these server RPC parameters. And this will, on the client side, you don't actually need any of the actual method calls here. It's just going to be an empty call because this is not running on the client side. Here on the server side, it will actually run, and this is where your actual code block is going to live. So this gets passed to the player, to the server, which will then for this particular function, this is if you were to call a spawn player manually, this is how you would actually go about doing it. So for this, like I said before, when you were setting up a UI for this, you would send over a character index, and then also this RPC params. This will actually be the client that actually sent this. So to spawn an object on the server side here, this is all happening on the server, you first just have to instantiate it, and just instantiate it like normal GameObject.instantiate. But then you also have to get the network object of that prefab, and then there is a spawn as player object function of network object. There's also just straight up spawn if you're spawning like missiles or bullets or whatever. And to spawn as a player object, and then you give it the client ID to spawn it as. Now, this is a special case here for this particular RPC. This I set up to for when the player spawns in, it's going to send its own data to the server. So here on the client side, I've got a player script. So I guess we could talk about this really quick. So I made my own network variable. And to do that, you just need to make a struct that implements the network serializable. And with this will allow you to send your data across the network through RPCs and stuff. So this is just going to have a int for the player ID, a string for the display name, and also I have a deck card system kind of set up. This is also a custom network variable, which is just an array of cards. The cards is also network serializable, which is just an ID and a power. I haven't implemented like any of this yet, but it's there. And I guess it works. I haven't actually made any cards for it, but it doesn't throw me any errors when I do this, so I'm assuming it's working. I have also set up on the actual player a bunch of other network variables that I want to sync up eventually. And then each one of these network variables also has an onChanged that I am subscribing to, that I'm not actually doing much with right now. But anytime any of these changes from the server side, I'll know and I can actually do stuff with it. But on Connect, which I just subscribed to from the Network Manager Singleton, what I'm doing is I'm just grabbing the player data that I've saved out locally, and then I am sending this to the server. I could technically use an RPC on the player to sync itself up, but I wanted to just demonstrate this to make sure that it actually works. So this is going to send it from the game manager. It's calling send player data to server. I do also have one here. No, I didn't actually set that up. Yes, I did, up here. So I just made a local one that will just do basically the same thing. So on the player, it is syncing up between itself. On the game manager, because it is being spawned by the server, the game manager is actually owned by the server. So in order to call a RPC on an object that you don't actually own, it needs to be, you need to have this attribute set up is require ownership equals false. Otherwise, you'll get an error message that says something like, you don't have permission to do this because it's owned by the server. And then what this is going to be doing on the server game object is this is going to be adding that player to a list of players. And in theory, I was going to add the client and the player just so we can map those together. Because for the most part, what you'll be getting from the client is just the client ID. So when a new person joins or leaves, the only thing you'll get is a client ID on when that person joined or left. So mapping it up to a player just gives me a little bit more info on like their player name and stuff. So that is what was going on here. I also set up the player data as a scriptable object, but that's for another time. So I can just change my display name to something else.
So would you really ever want to take and send your player data from the player to the server? Wouldn't you want to just have it say, okay, hey, I'm logging in, and then have the server just pull up whatever that player's last info was and load it?
Ideally, yeah, but I don't have a whole player system set up that requires like a whole back end and stuff. I mean, if you were doing like PlayFab, that's exactly how you would do it. You would just log in, and then all that player is just stored on PlayFab servers. But I didn't set up any of that stuff here.
Okay.
So here, wrap. Close that. All right. So yeah, that's just the basics of RPCs. Object visibility. So here on our server, let's load this up a little bit. Do you still have that synced up? Okay, good. So here we'll just have, we've got a cube. Set in the middle. And that's fine. So because this is on our server and we've got a network object on it, I think. Okay, that's fine. So for network objects, they have this check object visibility um, delegate here. And what this does is on a client connection, it will check to see if this client is, this object is visible to this client. This is normally just run once on connection. So, for example, if this was like a real-time strategy game, and you have like a fog of war, and so when you connect, you want all of the enemy's players' units to be not visible to the player, and this is how you would actually set that up. So if it returns true, then it gets it's visible, so it will get spawned on the client. And if it's false, it is going to not show. So this is a little code snippet from the Unity docs there. And what this will do is this just calls a vector3.distance from the player client or from the player object to this actual game object. And if it's less than 5 units away, then it will if it's less than 5, it'll show it. If it's greater than 5, then it gets disabled. So on spawn, this is just spawning, I believe, just in the middle, and it's at 0, 0, right? So this is going to be spawning directly on the player, so we should see this cube show up, even though we're playing here. It doesn't actually have any game objects in it. What's going to happen is because we have our prefab sync set up on our network manager, it's going to spawn all of our server objects onto our client. You just have to make sure that your prefabs are actually set up here in the network prefabs list. So if we just play this, here, we have our cube. Now on our player, where did I put that? It's on the actual server. Oop. So on our player object on the server, I have this area of interest. So what I have here is just an on trigger enter and on trigger exit. And when this gets, when it exits the trigger volume, it is going to call this network object hide, and it's going to hide it from this client. So it's going to hide it from ourselves. And when it gets inside this volume, we're going to show it. So network show and network hide will spawn and despawn the object from the client. I guess we can. So as you can see on the server side, it's still there. And technically, other users would be able to see this as well, but it's outside of my range. And when it goes back into my range, it shows back up, and all of the variables and whatnot will be synced back up to it. So that you would use this. Ideally, this would be your trigger volume would be like beyond the camera visibility range. So if this was like this camera style here, your volume should be probably greater than your actual camera field of view, just because you don't want stuff popping in and out while you're actually playing. But this will save on bandwidth if you have particularly large open world scene. You don't need to have your objects updating and sending data for stuff that you aren't interacting with or can't even see.
Seems like that would be pretty good for like anti-cheat stuff too, where you're reading memory and because it's actually removing it from the memory on the client. It looks like.
Yes. Yeah. So like for enemy team stuff. So if you don't want um, things to show on your client for like opposing players stuff, whatever that actually is, you can just hide it from the player. And yeah, those updates just don't come across the network at all.
That's really cool.
Yep. There's probably a better way of doing it beyond like putting triggers on the server side, but this was nice and easy to do and easy to explain. So, and I guess we can just do this real quick. Yoink. Show it off a bit. Should be fine. See how that works. Cool. Yeah, I should have moved the camera to something better. But anyways, that's the idea of that. And finally, we can talk about custom messages. Yeah, that's a good thing to wrap up on. So, this is the client. Okay. So say you don't actually want to use RPCs to send messages back and forth to different objects or whatever. What you can do is use this custom messaging manager, which is part of, I believe it is just part of Unity messaging here. Yeah. So there is a unnamed message callback, and there is also a named message callback. And I think I'm only using, for this one, is just using the unnamed. So what this will do is for an unnamed message, this doesn't have a message type or anything. This will just send a message, a stream, which is just a byte array buffer to, I believe this is just on the server side. This just sends it to everybody, or send it to the client. What I was doing with this is I was using this for the chat system. So I was sending a message to the server from the client, and then I was sending a message back to everybody. So on the client side, I have this client message handler. So on Awake here, what I have is I have a custom messaging manager here, and on unnamed message here, I'm just doing this inline. So this will receive a message. If you're the client, you're only receiving messages from the server. So this is just server ID, and then this stream, which is just our byte array. And what I'm doing here is I'm using this pooled network reader, which is part of MLAPI serialization pooled. Yeah. And this will it will spin up a reader, and then it will get this stream. I know that it is just going to be receiving a string. This could technically be whatever you're sending. Any of the, I believe it is, any of the primitives here. So you can have bits, bools, byte arrays, double arrays, floats, ints, all kinds of stuff here. But right now, yeah, vector 3s and 4s. This is just going to be strings. And I'm getting that string and then printing it, basically. And because it's unnamed, I don't know what type it is going to be or anything like that. I don't know anything about it. But for a named message, then this actually has a type to it. And it's a string, so it can be just whatever string you want. I set this up as a enum, just because I don't like dealing with strings and function parameters. But for each message type, you can have a different message handler. And the same way, it also comes with the sender ID and also the actual stream. So what I was doing here is in the string type, what I was doing is I just was sending this notification message, which is a little bit more complicated than I would have liked. But what I did here was I have a message type enum, which I'm setting up as just these various things for card game messages that you might want to send from a server. And I just made a empty interface here called network message that implements the iSerializable. And then I have various structs that implements network message. And for the serializable, I don't know if I messaged this, but the way network serialize gets called is that when it is reading this struct, it will serialize its members here. And when it is reading, it will deserialize it for you. So for this notification message here, it's just a string, and it will serialize and deserialize for you. And the reason I did it this way with an interface is that back here, I can just send a message, just a network message, and then on the receiving side, it can be whatever one of these I want it to be. Where's our server? So here on the server side, what I was doing was I was sending the unnamed message from the client to the server. The server will grab it, and all it's going to do is just read that string into this message string and then just send it right back out. And on this send function, it is just going to call the network buffer. And what this will do is this will create a buffer array, and then this writer from that buffer, and then it's going to write this network message into the writer, and then send that off with this send named message. So here I'm just sending it as a notification string with to said client, which was just the same one that I got. And then it's sending the buffer, which is what we wrote out to it. Then back on the client side, we are getting this named message of notification. We're making a new notification. We're reading it. We are reading the packed object of type notification message. And then I'm calling this this event here that I just made up. It's just a static Unity event, which other things can subscribe to. I don't remember where this is actually getting invoked. I may have removed all that. There. Nope, I think I removed it. But anyways, any other script can just listen into that this notification event and then do what you will with it. This is not really necessary to use with network variables that gets sent for you. So yeah, this would just be for like really specific instances. I could show how. Nope, that's under C's. Oop. There we go. So this is kind of important to keep in mind with RPCs and how they actually function here. For server RPCs, they are sent from the client and it is executed on the server. So what happens when you call an RPC? Also, I'm not sure I actually mentioned this, but server RPCs and client RPCs, they have to end with server RPC or with client RPC on it. It's using reflection, I believe, to make sure that to call on the receiving end. So it needs to have that actual in the suffix of the actual function call, and that's rather important. So yeah, what happens is when you send RPCs, it will serialize the parameters first and then send them on. So this is kind of a pseudocode on how server RPCs actually work. And these parameters here, they can be of those iNetwork serializables that you made earlier. So instead of using the custom messages, I could just use the RPCs to send that same network, that notification message. I could just send that through an RPC. And that's easier to do than doing it all custom yourself. Yeah, and finally, I guess it's the scene management. The only real change here is that when you are switching scenes, you just need to call network scene manager, and it's just dot switch scene, and you'll need to do that on the server side to make sure that the clients get all synced up. And you also just want to make sure that the network manager is set to don't destroy on load, which it is by default. So yeah, that is the basics of it. What's up, Steven?
I'm just curious, the scene management thing. So it seems like the clients and the servers, or all the clients don't necessarily have to be in the same scene, right? So what exactly is, what is the process like for that?
The clients, they actually do have to be in the same scene, because when a scene gets changed, all of its game objects gets unloaded from memory. So they do have to be in the same scene, and that's what that network scene manager keeps everything in track of.
So if you were to have different areas that are separate scenes, would you need to like run them like as two different rooms on your server and then move players between the rooms, or how would that work?
Right now, you actually can't. It can't be different scenes.
Okay.
What you would do I don't think you can load them additively yet. I think that's something they might be adding. I think. I hope. But yeah, right now it has to be in the same scene. So what you would do is you would just have a different set of terrain further out in the distance that you would just move the players to. You could also use the network show and hide to like hide different buildings or hide whole terrains if you wanted to, and then load in the new terrains. So that would be also a way to do that.
Okay.
To kind of set up like a little portal, like we did in that one game we did, where basically you get to a point, then you kind of just basically transport them to a different area, and that way they're then seeing that train or whatever you're wanting to take and have. And then if they ever go back, like let's say if you're going through like a doorway or an entryway and you see something different, once you walk through there, you kind of transport it then to the next one, so you're not having to change the scene.
Right. Yeah. Yeah. The network show and hide might actually be better in that case. I haven't actually tried that yet for whole areas, but it should technically work. And it's just spawning and despawning anyways. So depending on how big your area is, I don't know if that would like slow down your scene or you get some stuttering if you're showing a whole bunch of stuff at the same time. That would just require some other profiling and whatnot.
Yeah.
Cool. Anybody have anything else? It's almost 8 o'clock. Time to start wrapping it up.
Very interesting talk. Thanks, Steve. I was mostly curious about that in terms of like a Diablo type game or something where you have different dungeons and players going in and out of different ones.
Yeah, for this, yeah, you could actually for that type of game, you probably could switch scenes. Just you have to wait until like everybody was like in the portal and then switch the scene over to the actual dungeon.
Gotcha.
Yeah, like doing a team-based thing. So as soon as you like achieve the objective, then you can kind of just change the scene and just teleport everybody then into whatever the next scene's going to be for the next level or
Right.
whatever it's going to be. So.
Yep. Cool. So yeah, like I was saying in the beginning, though, they are. This is still in preview and in active development, and in their on the GitHub there is a develop branch that is that O.2 branch that's currently working that they said was going to be out here relatively soon. That is has a lot of fixes and new features and stuff. So we might have to revisit this. Well, we probably will have to revisit this in another year or so. But yeah,
Did you post the link to your project?
I could if it was on GitHub. I'll put it up there.
No, you don't have to. I was just thinking it might be. It seems like you added a lot of, like you customized it a lot. So curious.
Yeah, sure. Yeah, I can throw it up there. I mean, there's nothing too fancy about it. But yeah, I can throw it up on GitHub. Both projects. They're technically two different projects, so I can put the client and the server up there, and I'll put a link to them in the description.
Cool. Thank you.
Awesome. All right. Okay. So yeah, we'll also throw this up on YouTube, probably later tonight. So yeah, thanks everybody for coming out. And
No, thank you. Thank you. I enjoyed it.
Thanks. You are welcome. So yeah, later tonight I think we'll be doing game night. So I don't know. I'll probably be hopping on Genshin Impact, maybe Valheim if anyone else wants to join me.
Yeah, nah. I'm taking away this time from the wife. I'm gonna have to take and spend the rest of the night with her.
I gotcha. Not a problem.
I got to make some food, but we'll see.
Yep, same. All right, guys. Well, I will see you guys next month, and thanks for coming out.
Thank
Later.
you.